I was out for a quiet walk when I spotted an old light bulb on the ground. Brought it home, flipped the switch, and nothing happened. And that moment pulled me back to a time when broken things were challenges, not trash. I stood there for a second, holding that bulb in my hand. And I knew I did not want to toss it away. I wanted to see if a little time and a simple fix could bring it back to life. First, you want to clean the bulb before doing anything else. I take it out of the socket and place it on the workbench. Using a paper towel with a little rubbing alcohol, I wipe around the base and the glass. Years of dust and grime can hide cracks and make handling slippery. Cleaning it also helps you see what you are working with and keeps your hands safe. This simple step sets you up for everything that comes next and only takes a minute. Now it is time to open the bulb and take out the circuit board. Hold the bulb steady and carefully pry off the plastic cap at the base using pliers or a small flat tool. Go slow so you do not crack the glass. Once the cap is off, cut the old power wires and gently pull the circuit board free. Remove any loose wires or extra parts so the board is clean and easy to work on. Take your time here and keep everything neat. Before we move on, share your city and state. It helps me make better projects for you. Now we prepare the new LED light strips. I use an LED strip that I know is still working well. First, I lay the circuit board on the table and measure the length I need. Then I cut the LED strip into short sections that match the curve of the round board. Do not rush this part. Each piece should fit without bending or forcing it. Laying them out first helps you see the pattern and make sure the light will be even later. This step is about patience and planning, not speed. Now it is time to attach the LED strips to the circuit board. I flip the board over so I am working on the back side. I use a thin, even line of hot glue and press each LED piece down gently. You want the strips to sit flat and follow the round shape of the board. Do not overlap them and do not leave gaps. I work one piece at a time and hold each one in place for a few seconds until the glue sets. If you rush, the strips can shift and the light will look uneven later. Take a moment to check that every piece is secure and pointing the same direction. This step matters because good placement gives you steady light and fewer problems when you power it on. Once everything is glued down, let it cool for a minute before moving on. Now you solder the LED wires and the main power wires. Heat up your soldering iron and make sure the tip is clean. Touch the iron to the positive pad on the LED strip and add a small amount of solder until it flows. Do the same on the negative side. Keep the iron on the joint only a second or two so you do not overheat the LEDs. Next, solder the two main power wires to the positive and negative points that feed all the strips. Give each joint a gentle tug to make sure it is solid. When you finish, take a quick look to confirm there are no loose strands or solder bridges. Now it is time to tidy up the wiring and test the lights. I trim one small corner of the circuit board so the wires can pass through without bending. Then I pull all the LED wires together and group them neatly. I twist them into two clean leads, one positive and one negative. Keeping the wires organized makes the next step safer and easier. Before going any further, I test everything with a 12-volt car battery. I touch the positive wire to the positive terminal and the negative wire to the negative terminal. Right away, all the LED strips light up at the same time. That is the moment you want to see. It tells you the wiring is correct and the LEDs are healthy. I remove the battery right after the test and let the board rest. Now I know this setup is ready for the power system. Now we prepare the NOKIA BL5CB batteries. I take a few old NOKIA batteries and check each one with a multimeter. You are looking for batteries that still hold some voltage and are close to each other. I select 3 batteries that still have life left in them. Next, I line them up side by side and wrap them tightly with electrical tape so they stay together and do not move. After that, I lightly sand the metal contacts on each battery. This removes oxidation and helps the solder stick better. Take your time here and keep the contacts clean. Now I solder the batteries in series, positive to negative, so the voltage adds up. Make sure each connection is solid before moving to the next one. Once the 3 batteries are connected, I solder 4 wires to the pack for the next step. 2 wires will be for power in and 2 for power out through the protection board later. Double check the polarity before you move on. This battery pack is the heart of the project, so careful work here makes everything else easier and safer. Now it is time to add the 3S BMS to protect the battery pack. I take a 3S 12.6 volt BMS and place it next to the 3 NOKIA batteries to check the fit. Once I am happy with the position, I use hot glue to secure the BMS firmly to the battery pack so it cannot move. Next, I connect the 4 wires to the correct points on the BMS. One wire goes to the first battery at 4.2 volts, the next to 8.4 volts, and the last to 12.6 volts, following the markings on the board. Take your time and double-check each connection before soldering. A wrong connection here can damage the batteries. After everything is soldered, I wrap the whole battery and BMS assembly with electrical tape. This keeps the connections protected and prevents short circuits. Now the battery pack is safe, balanced, and ready to power the light properly. Now we install the push-button switch. I choose a spot at the bottom of the old bulb where your thumb naturally rests. That makes it easy to turn the light on and off later. I carefully fit the switch into the opening and make sure it sits straight and tight. Then I connect the wires from the battery pack and the LED board to the switch terminals. Take a moment to check the connections and gently press the button a few times. You should feel a clean click. This small switch gives you full control of the light and makes the project feel finished and practical. Now we install the DC charging jack and connect all the wiring. Start by choosing a solid spot on the plastic base of the bulb. You want enough thickness so the jack will not wobble. Drill a clean hole that matches the size of the DC jack. Go slow and keep the drill straight so the jack fits snug. Insert the DC jack into the hole and tighten it by hand. Make sure it does not spin. A loose jack can break wires later. Now identify the positive and negative terminals on the DC jack. Most jacks are marked, but if not, check with a meter before you solder. This step matters. Next, connect the DC jack wires to the BMS charging input. Solder the positive wire from the jack to the BMS positive charge pad. Then solder the negative wire to the BMS negative charge pad. Hold the iron steady and let the solder flow clean. Do not leave the iron on the pad too long. After each joint cools, give the wire a light tug to confirm it is solid. Now connect the output side. Run the power from the BMS to the push-button switch. From the switch, run the wire to the positive lead of the LED board. Connect the negative lead from the LED board directly back to the BMS negative output. Keep the wires short and routed along the inside wall of the bulb. This helps everything fit and reduces stress on the joints. Once all connections are made, insulate every exposed joint. Use heat shrink if you have it. If not, wrap each joint carefully with electrical tape. Make sure no bare metal is visible. Take your time here. Good insulation prevents shorts and keeps the light safe to use. Before closing the bulb, do a quick test. Plug in a DC charger with the correct voltage and press the push button. The LEDs should turn on clean and steady. If everything works, unplug the charger and move on. This step ties the whole project together and turns an old bulb into a rechargeable light you can rely on. Now it is time to secure everything inside the bulb. I apply hot glue along the inner wall and gently press the battery pack into place so it does not shift. Next, I position the LED board at the front, making sure it sits straight and centered. Take a moment to check that no wires are pinched or stretched. Good wire placement helps the light last longer. Once everything is set, I add a bit more hot glue to lock the parts in place. Do not overdo it. You want the part secure but still neat. After the glue cools, I carefully snap the plastic cap back onto the bulb. Give the bulb a light shake to make sure nothing moves inside. At this point, the build feels solid and ready for everyday use. And just like that, an old broken bulb is now a useful rechargeable light you can hold in your hand. You turn scrap parts into something practical with simple tools and a bit of patience. If you enjoy fixing things instead of throwing them away, hit like, subscribe to the channel, and share this with someone who still believes good tools deserve a second life.